So the chapter 12 is about analytic geometry. We're going to start out with conic sections. Conic sections, basically, if you set two cones on one upside down and the other right side up, and you slice through it certain ways, you get these particular things. So they were called conic sections for that reason. We are going to do circles, ellipses, hyperbolas, and parabolas. They are important that we understand when we look at the equation what something is. It's very helpful if we understand kind of the basics of those equations, and that's what we're going to look at. Circles is where we're going to start. We're doing the very basics of a circle, so you'll find circles are really nice because of the symmetry of a circle. The equations are nice. They all kind of flow correctly. You know, you'll like circles. Circles are important where we're leading to, because chapter 7, we're going back to chapter 7 for trigonometry. So it's really just important because circles play such a big role in trig. So the equations that you want, you'll see right here. The equations of a circle, if you have a center of your circle at 0, 0, so at the origin, x squared plus y squared equals r squared would be the equation of your circle. So if you just see the x squared plus the y squared equals a number, the number is the square of your radius. So if you want your radius, you have to take the square root of that. Now, you might recall that if we had a vertex of a parabola, we called that HK. You'll see that same language right here. See that H and K. If we have a center at H and K, your equation changes a little bit. You subtract the H inside of the square of the X. That would be the amount you've moved left or right. And then your K is how much you're going to move up or down. You still are equal to some number R squared. Okay, so if you look down here at this equation, this is a circle with center at 3, 3, whose radius is the square root of 4 or 2. So you're always taking the square root of that number. So that's the difference in these two equations. This one is centered at 0, 0. This one is centered at 3, 3. They both have a radius of 2, and it's always the square root of that number. Now, it's great when the square root is actually a nice perfect square, but don't expect that it is a perfect square. If it is not a perfect square, get into the habit, please, of just maybe, because it's a graph, like maybe estimating to the nearest tenth is usually pretty good. That's a good way to go if worse comes to worse, okay? So that is how you can work through that. So you'll just have to recognize x squared plus y squared equals r squared, and recognize that that is a circle. Now, if you change that to an x squared minus y squared, you get an entirely different equation. If one of them is squared and one of them is not, you get a different equation. So these equations, you have to recognize that x squared plus y squared equals a number is going to give you a circle, okay? Now, circles are pretty straightforward, pretty basic. You'll find when we go to try to create those equations, all of those things will work out pretty nicely. Okay, so here's one. It says to graph a circle with center at 2, -1 with a radius of 4 and find the equation of the circle. So let's go and draw it first. So we're going to go to the point 2, -1. We're going to put a point at that spot, 2, -1. We're going to put a little C there. It's customary to mark that as such, so please do that. And then because we have a radius of 4, take from that point, count 4 to the left, 4 to the right, 4 up, 4 down from that point, and put a dot. So I'm going 4 to the right, 4 to the left, 4 up, 4 down. And so that's going to give me a nice circle. Now, there was a time where I could have moved that beautiful circle, but I can't. We can't. So we're just going to go through those points. And if you're using something like Notability, they do allow you to make a circle. Okay. Now, we've drawn the circle. You'll see drawing a circle is very nice if you know the center and the radius. Very perfect. Great. It's quick. But let's talk about finding the equation. So I want you to write down the general form, which is x minus h squared plus y minus k squared equals r squared. Now, that's a formula you want to know that is associated with any general form of a circle. Now, let's also remember what else we know. We know that 2, -1 is our h and our k. So that's our h and that's our k. Now, when they tell us that the radius is 4, that is our r. That is not r squared. So we can even calculate r squared in our head or with a calculator. So now we know our h is 2 and our k is -1. We know that our r squared is 16. Let's go ahead and place those things into our formula. So we're going to get x minus 2 squared. Now, we are subtracting k. If k is already negative, that means we are subtracting a -1. So just get in the habit of changing the sign whenever we plop it into the formula. So that's a +1. And we have found that that has happened again and again and when we have used that type of formula. Now, our r was 4, so r squared is 16. You can write 4 squared there, but eventually please change that to a 16. That's the equation I want. So here we have the equation for our circle. Let's find the radius in the center. Let's work our way backwards. Now, I'm going to write this down. And underneath it, I'm going to put x minus h squared plus y minus k squared equals r squared, kind of as an illustration as to what's happening. Well, up above, technically, that's really x minus nothing squared. X squared is x minus nothing. That's where our h is equal to 0. Y minus k, above there you see y minus 1. That means that our k is equal to 1. And it is. It's always that opposite of what we see. And then we've got 9. So r squared was 9. So r is the square root of 9. And that's where I got the 3. So we know that our center is 0, 1. And our radius is 3. So going backwards is even pretty nice. Not a hard thing to do. Now watch the way that your graph paper is numbered. You'll see I did put the 3's on there at least. So we're going to go to the point 0, 1, which is right here. Mark it as the center. Put a little C there for me, please. Our radius was 3. So from that center point, count exactly up 3, down 3, left 3, right 3. Once you have those points, do your best to make a circle. When I always draw it by hand, I always tend to, it looks kind of like a football. Okay. So I always like circles. Circles are pretty straightforward. They're just, there's not a lot that you have to mess with. Now, obviously, there's some algebra that can go into this, especially if the squares are not completed. So you might recall back in algebra, completing the square could be possibly a part of this lesson. Everybody got example 2? Okay. Now let's do this one more time as far as getting the equation goes. We're just going to practice a few more. It says, what is the equation of a circle with center -2, 4, and a radius of 6? So again, remember, you need to know by heart that x minus h squared plus y minus k squared equals r squared. They have told us that our hk is -2, 4. So when you plop it into the formula, just make sure you do the opposite. And that our radius is 6, so r squared would be 36. So we got all that information. As long as we have in our memory banks that formula, x minus h squared plus the quantity of y minus k squared equals r squared, you can find the equation of a circle really nicely. Let's plop those things into our formula. So that's x plus 2 squared, y minus 4 squared equals 36. So you'll notice, main things to notice, these two are opposite of what we see here. They should always be the opposite, and this should be the square of our radius. So if you got that, very easy to go to the equation of a circle. Now again, they're not always going to be nice and pretty like that. We will, I think, do one example where we have to manipulate the equation a little. We good there? Okay. So let's just practice graphing another one just till we have the practice here. So we have our equation x plus 2 squared, y minus 3 squared equals 1. So if we think about our general form of our circle, x minus h squared plus y minus k squared equals r squared. Our h is going to be the opposite of what we see here. So our h is going to be -2. Our k is going to be the opposite of what we see here. Or you can always do the thing where you set that quantity equal to 0. It'll work every time. And then, so our y is going to be 3. Now remember, r squared is this number right here. So if r squared is 1, then r is going to be the square root of 1, which is also 1. So we have a center at -2, 3 with a radius of 1. So graphing, it's really nice. We're going to go over to the point -2, 3. We're going to mark it with a C. Count up 1, down 1, left 1, right 1, and make a circle. Okay. And that's how you graph circles. They're just nice. It's the symmetry of them, everything about them are nice. And and they're going to relate a lot to what's coming up in trigonometry, as far as the fact we do use the Pythagorean theorem has an x squared plus y squared equals a number squared. We're going to do something called the unit circle, which uses all these different things that go along and go with this together. So the last example, I believe, the last example are the most difficult when they aren't in that nice general center equals radius squared form. So let's practice how we do that. So if you look at an equation like this, and the highest power on our x is a squared. It's positive. The highest power on our y is a squared. It is positive. They have the same coefficients, so they're both a 1x squared, and it's equal to 0, or in this case, if you move it over a number, that's going to tell us we're dealing with a circle. Now, to get it into that form we like, we got a little bit of work to do. So we're going to put the x's together. So I'm going to move that 4x with the x that's there. And then I'm going to put a little blank as a little placeholder so that we can do something called completing the square, which you probably did in Algebra 2 and we might have touched upon already. Now, what's great about our y is always already a perfect square. It doesn't have any extra piece hanging off there because we can't have any extra y's or other pieces hanging off there. And you'll notice that I haven't used that 8 yet because the equation of a circle is always equal to some number. So let's move the 8 to the other side by addition. And because we have a blank on the left, we're going to put a blank on the right as a placeholder. Because remember how equations work, whatever I add to the left, I also have to add to the right. Okay. Now, we're going to complete the square for that section first. Okay. So how could we make that a perfect square? Here's the procedure you always want to go through. In the parenthesis below, we are always going to use half the coefficient that we see there. It's always half of that. It's always half of positive 4x. Well, what's half of positive 4x? Or the coefficient positive 4 would be positive 2. Now, it's always going to be half of that, okay? So this one's always going to be an x. This one's always going to be half that coefficient, okay? So half of that goes there, and then we're going to take this number and square it. So it's going to be a positive 2 squared. Okay, so let me go over it again. We're always going to use half that coefficient. It's going to go down in our x plus or x minus parentheses, and then that number squared fills that spot. Now, whatever we add to the left, we're going to add to the right. Now, 2 squared, just do that. Whether you have to rely on a calculator, in this case, 2 squared is 2 times 2, 4. So put a 4 on that one. So I usually put the math I'm going to do on the left and the actual number on the right because I need that number on the right. And so we get the quantity of x plus 2 squared plus y squared equals 12. Now, it's the formula like we want to see it, right? It's x minus h squared plus y minus k squared equals r squared. It's great. It's good. That's the equation we want. So what's our center? Well, our h is the opposite of what we see there. So negative 2. Our k is the opposite of what we see there. We see nothing there. That tells you that we're nothing is 0. So our k is 0. And then our r is the first time it's a little bit of a funky one. R squared is 12, so r is the square root of 12. Now, the square root of 12 is not a great way to write that. If you were going to put that into a calculator, it's 3 point something, maybe like 3.7 or 8. I don't know, put it into a calculator. But for my purposes, since 12 is 4 times 3, the only perfect square contained in the number 12 is 4 times 3. And so I can do the square root of 4, but I can't do the square root of 3. So I prefer that you write it in its reduced radical form, 2 radical 3. So our center, so the answer is our center is negative 2, 0. Our radius is 2 radical 3. So now let's do the same exact thing for part B. Okay, now luckily the x's are together, so we're going to put the x's together with a blank. Now this time our y's need fixed, so we're going to put our y's together, which they've done. If they aren't in order, you can just rearrange the order to fit what we want, plus a blank. We're going to move the 11 to the other side. When it moves to the other side, it always changes sign, so that's going to be a positive, and I have 2 blanks this time, so make sure you have 2 blanks. So all I'm doing is just a little rearranging to make everything all lovely, hunky-dory, pretty and shiny and lovely. Okay. So put a little parentheses underneath with an X. Put a little parentheses underneath with a Y. That's kind of just our little, let's put everything in its place, getting ready. Okay. So what do we got to do? Well, half this number fills this spot. Half of -6 is -3. -3 squared fills that spot. What is -3 squared? Just do that in your head or put it in a calculator. You always want to include it in parentheses. It's always going to end up being -3 times -3. So it's always going to be a positive number that you add to the other side. Now that's what we do for the x's. We're going to do exact same repeat for the y's. Half of this number, the coefficient, fills that spot. So half of +8 is +4, and then +4 squared needs to fill the spot on both sides. Well, +4 squared is just +4 times +4, or 16. And now just add up those numbers on the right. So 11 plus 9 is 20. 20 plus 16 is 36. And now we got it. Look what we got. We got every single thing we need. Our h is going to be the opposite of what we see there. Our k is going to be the opposite of what we see there. Our r squared is 36, so r is 6. So if we had to draw this circle, we would put the center at 3, -4 with a radius of 6. Now we got it. So completing the square is the hardest part to do with the circle. It is a technique that you need for all the conic sections. You can use that same technique for ellipses that are coming later on, and hyperbolas and parabolas. Completing the square is an essential tool that's really helpful. And we'll keep repeating it and practicing it, and I'll keep showing you. Now, your homework is what you see here. So for 1, 2, and 3, you have the center and the radius. I want to see it plopped into the formula. So I want the equation that would match it, and then just graph it real quick. It doesn't have to, just a little sketch is fine by me. For 4 through 10, we're going the opposite way. Tell me the center and the radius, graph each one. Ignore that little line. I think I captured my my cursor at the time. And then 11 and 12 are the only ones that you have to put into the correct form because you have to complete the square. So that's what those ones are like. So that is your circle stuff. So for the remainder of class, if you could work on that, that would be awesome.